Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. These are solvolysis reactions of isonorbornyl nosylates, sulfonate esters, with water. The key mechanistic feature is neighboring group participation and chimeric assistance by the double bond, pi bond participation, in the norbornene system. The ichOns undergoes ionization assisted by the C is equal to C pi electrons, forming a non-classical carbocation, a norbornyl cation stabilized by homoconjugation pi participation. The rate of solvolysis depends on how well the double bond can stabilize the developing positive charge in the transition state. Moving on to the next step. Identify the effect of methyl substitution on the double bond. In structure, I unsubstituted double bond, no methyl groups on the alkene carbons. Pi participation is present but unenhanced. In structure, to one methyl group on the double bond carbon, C3 methyl norbornene nosylate. One methyl group increases electron density on the double bond, modestly enhancing pi participation and stabilizing the cationic transition state. In structure, 3,2-methyl groups on both double bond carbons, 2,3-dimethyl norbornene nosylate. 2 methyl groups provide maximum electron density to the double bond, giving the greatest pi participation and the most stabilized non-classical carbocation transition state. Moving on to the next step. Greater alkyl substitution on the double bond, greater electron density available for pi participation, greater homoallyl pi assistance, lower activation energy, faster rate of solvolysis. Therefore, 3, 2, I. And for the final step. A, I, 2, 3. This would imply more substitution slows the reaction, the opposite of pi participation logic. B, 2, I, 3. This is inconsistent, the desubstituted alkene should be fastest. D, 3, I, 2. This would mean one methyl group is worse than no methyl group, which contradicts the electron donating effect. Only option C, 3, 2, I, is consistent with increasing pi bond electron density, facilitating homoallyl pi participation in the rate-determining ionization step. Therefore, the correct answer is C. Therefore, the correct answer is option C.